The primitive rules of chapter 3. So we have several new primitive rules. We have rules for both the existential and the universal. So we have a rule for called universal instantiation. This says if you have for all x fx, you can infer fa, and the fx can be bigger, so it could be like for all x if fx then gx. And a can be any term, so a can be either a name or a variable, whichever one you want. And it's abbreviated as UI. There are some binding restrictions on this rule, which I'll talk about in a little while. Actually, I'll talk about those in the next video. There's a rule called existential instantiation. So that's if you have some x fx, then you can infer fi. Again, the fx could be more complicated. It could be fx and a gx, and then you get fi and gi. Here, a has to be a new variable. New meaning that it occurs nowhere in the derivation or in the premises of the derivation. And this is called EI. And finally, we have a rule called existential generalization. It says if you have FA, then you can infer some x fx, and again, A can be any term. So what for all x fx, what universal instantiation says is if everything is f, then whatever name you stick in there in place of x, whatever variable you stick in there, whatever it refers to, it's f. Existential instantiation is a little bit more complicated. I'll talk about it later. Existential generalization, if you know Alfred is a frog, then something is a frog, right? So whichever thing, if we know that a particular thing is a frog, then we also know that something or other is a frog. And we call this rule EG. So I want to talk about why the rules are sound or truth-preserving, why if the premise of one of these rules is true, then so is the conclusion, and that'll help to sort of also understand more about what the rules are saying. So we'll look at some examples in English. So if we say everything is such that it is tall, then we can infer Bob is tall. And we said everything is such that if it is a whale, then it is a mammal. We could infer if Bob is a whale, then Bob is a mammal. And we could even just say, if we said everything is tall, we could infer Bob is tall. And if we said everything that is a whale is also a mammal, we can infer if Bob is a whale, then Bob is a mammal. And if we just said every whale is a mammal, then we could infer if Bob is a whale, then Bob is a mammal. So, and it's nothing special about Bob. You could put in any name there you like. And all these are examples of universal instantiation, and they're all pretty clearly true. If you say that everything has a certain property, then whichever name you pick, whatever it refers to, it has that property. And so if the premise is true, so is the conclusion. Then it's up to you, right? You'll get to choose which term to instantiate to, and you can apply UI more than once, because if everything is F, then Alfred is F, and Bob is F, and Carol is F, and Debbie is F, and so on. Okay, let's look at EG. So if we say that Opus is a penguin, then we can infer something is such that it is a penguin, yeah? Or if we know that Opus is a penguin and Opus is evil, then we can infer something is such that it is both evil and a penguin. Or we could just say some penguin is evil. So these are all examples of existential generalization, and again, they're pretty clearly truth-preserving. What about existential instantiation? Well, so suppose you knew that something is a penguin. You know that there is a penguin, and you know that every penguin is evil. Well, it follows that something is evil. It actually follows that so it follows that something is evil. But we may not know which thing is a penguin. Maybe we don't know about Opus, and we don't know, all we've been told is very reliably that there are penguins, but we don't know of any particular thing that it's a penguin. Lacking that knowledge, we can still infer to something is evil. So, so we don't know which thing is a penguin, but there is one. And since every penguin is evil, that thing that is a penguin, it's evil. And so therefore, something is evil. So what happens here is, note this it. The word it here. We say we don't know which thing is a penguin, but we know there is one. And so whichever thing it is, since every penguin is evil, it's evil. So that it, what are we doing with that it? Which thing is it referring to? Well, it's not really clear what it refers to. It's kind of being used as a stand-in. What we know is there is a penguin out there. And so if it referred to that penguin, then this would work. And so what we do is we say, we know there's at least one penguin and we want to talk about one of them, but we don't know which thing it is. So what we're going to do is we're going to introduce we're going to introduce it into the sentence and say, look, just let it refer to one of those things that is a penguin. We know they're out there, and so let it be a name for one of them. When we do that, all we know at that point about the referent of it is that that thing is a penguin, and we don't know anything else about what the word it is referring to. All it does is make the existential generalization true. And so that's what's happening with our SUMX FX FI rule in the logical language. The EI lets us instantiate to this it. But we need to have this restriction that we don't know anything about which thing it is besides that it makes the existential generalization true. And so the way in which we enforce that restriction, that we don't know anything else about the referent of it except that it makes the existential generalization true, is we make I be a new variable. So we're making it so that we don't have any information about I. And so that's why we have the restriction.